Hello, my name is Robbie Jones, and welcome to my presentation on Ansible. First, we'll go over a little bit about what Ansible is and what it can achieve for your projects. Ansible is a simple automation language that can depict an IT application infrastructure. It's open source and provides things like automatic deployment, which allows you to deploy applications automatically on a variety of environments. We can also include configuration management and IT automation, which maintain the consistency of all systems in the infrastructure and use the instructions to automate the IT professional's work. Now that we know a little bit about what Ansible is, we'll go into why you should use it and how to implement it into your projects. Ansible is more efficient and more secure than other automation tools by using OpenSSH and WinRM. When you install Ansible, you only need to install it on one machine, and it can manage an entire fleet of remote machines from that central point. And since we are managing remote machines using OpenSSH, it does not leave software installed or running on them, so there's no question about how to upgrade Ansible when moving on to a new version. Secondly, Ansible powerfully orchestrates the app lifecycle with easy app deployment and configuration management. And finally, Ansible is prided on its simple implementation that can be understood easily by people even without a deep understanding of programming and coding. This allows anyone to get productive quickly. And now that we know why you should use Ansible, we'll go into the steps to installing it and some tips on how to use it. Installing Ansible is quite simple. You can easily install Ansible with the pip package management system to be used with Python, as shown with this line, pip install Ansible, after downloading the version you need from the website. And now we'll go into a little bit about how Ansible actually works. Ansible works by modeling your IT infrastructure by describing how all of your systems interrelate, rather than just managing one system at a time. It uses no agents and no additional custom security infrastructure, so it's easy to deploy. It works by connecting to your nodes and pushing out small programs called Ansible modules to them. These programs are written to be resource models of the desired state of the system, and then executes these modules over SSH and removes them when finished. And now that we know a little bit about how it works, we will go into writing your own Ansible configuration with things called playbooks. Playbooks are the backbone of the configuration that Ansible uses to define work for a server. An Ansible playbook contains one or more plays, each of which define the work to be done for a configuration on a managed server. By composing a playbook of multiple plays, it is possible to orchestrate multi-machine deployments running certain steps on all machines. This is a little example of a playbook that starts an Apache web server while making sure it is running at the latest version. Here's another example of a playbook, and you can see the different elements that come into writing a play. And this includes things such as a host selector, privilege escalation, variables, and tasks. A playbook can also implement templates, loops, conditionals, tags, and blocks, which we'll go into next. Templates in an Ansible playbook are used to set and modify play variables, handle conditional logic, and generate files such as configurations from variables. Loops can be used to do one task on multiple things, such as create a lot of users, install a lot of packages, or repeat a polling step until a certain result is reached. Ansible also supports the conditional execution of a task based on the runtime evaluation of variable, fact, or previous task result. And tags are useful to be able to run a subset of a playbook on demand. Blocks can also be used to cut down on repetitive task directives. This allows for logical grouping of tasks and are even used in play error handling. Next, we'll go into Ansible modules. Modules in Ansible are bits of code transferred to the target system and executed to satisfy the task declaration. These are reusable standalone scripts that Ansible runs on your behalf, either locally or remotely. Modules interact with your local machine, an API, or a remote system to perform specific tasks like changing a database password or spinning up a cloud instance. A module provides a defined interface and accepts arguments to return information to Ansible by printing a JSON string before exiting. Now we'll get into some module specifics and talk about writing your own module. Command modules take the command name followed by a list of space-delimited arguments. These should only be used when Ansible doesn't have a module you need and should only be used as a last resort. The shell modules take the command name also followed by a list of space-delimited arguments. It is almost exactly like the command module, but runs the command through a shell on the remote node. The script module takes a script name followed by a list of space-delimited arguments. The local script at a path will be transferred to the remote node and then be executed. Then the given script will be processed through the shell environment on the remote node. Raw executes a lowdown SSH command, which is useful but should only be done in a few cases. A common case would be installing Python on a system without Python installed by default. Another is speaking to any devices such as routers that do not have any Python installed. Now that we have covered modules, we'll go into another configuration tool for Ansible called inventories. The Ansible inventory file is a collection of hosts with associated data and groupings that Ansible can connect to and manage. The inventory file defines hosts and groups of hosts upon which commands, modules, and tasks in a playbook operate. The file can be in one of many formats depending on your Ansible environment and plugins. This enables you to define groups of devices running the Junos operating system with similar roles upon which to perform the same operational and configuration tasks. And this is a little example of a static inventory listing examples of hosts that you can connect to. Next, we'll go into ad hoc commands. An ad hoc command is something that you might type in to do something quickly but don't want to save for later. This is a good place to start to understand the basics of what Ansible can do prior to learning the playbook's language. They can also be useful to do quick things that you might not necessarily want to write a full playbook for. For instance, if you wanted to power off all your lab for a Christmas vacation, you could execute a quick one-liner in Ansible without writing a playbook. Each play contains a list of tasks. Tasks are executed in order, one at a time, before moving on to the next task. It is important to understand that within a play, all hosts are going to get the same task directives. It is the purpose of a play to map a selection of hosts to tasks. The goals of each task is to execute a module with very specific arguments, and variables can be used in arguments to modules. To finish up this introduction to Ansible, I'll remind you that Ansible's main goals are simplicity and ease of use. It also has a strong focus on security and reliability, featuring a minimum of moving parts, usage of OpenSSH for transport, and a language that is designed around understanding by humans who are not familiar with the program. Ansible believes that simplicity is relevant to all sizes of environments, so Ansible is appropriate for managing all environments, from small setups with a handful of instances to enterprise environments with many thousands of instances. Lastly, Ansible manages machines in an agentless manner. There's never a question of how to upgrade remote versions of or the problem of not being able to manage systems because newer versions are installed. This will conclude my presentation, and I hope you enjoyed learning a little bit about Ansible.